Atomic notation. Chemists use two basic notation systems to communicate information about the subatomic particles present within atoms. The most important piece of information is atomic number. It's given the symbol or abbreviation Z. This is the number of protons in the nucleus of an atom, and it gives an atom its identity. Typically, periodic tables show the atomic number toward the top of the elements placed on the table. Important to note that this number is never a decimal. Atoms on the periodic table are electrically neutral, which means that Z stands not only for the number of protons, but also for the number of electrons. Again, this only applies to neutral atoms. The final important element here is called mass number. It's given the abbreviation A. Mass number is the number of protons and neutrons. In other words, mass number is the sum of the number of protons and the number of neutrons. This is often called the nucleon number because the protons and neutrons are the particles that are in the nucleus of an atom. Try this. Can you determine the number of protons, the number of electrons, and the number of neutrons in this atom of uranium? The easy one to find is the number of protons. The atomic number in this particular type of notation, the one pictured on the left-hand side at the bottom of the screen, has the atomic number at the bottom. Because we know that uranium is also a neutral atom, we know that the number of electrons is also 92. The one that's a little bit more challenging is the number of neutrons. A lot of times people mix up mass number thinking that the mass number itself is the number of neutrons. Turns out the mass number is actually the sum of the protons and the neutrons. That means if the sum of the protons and the neutrons is 235 in this case, 235 minus the protons would give you just the neutrons, 143. Again, noting that 143 is not the same as the mass number, 235. Try this one. Determine the number of protons, electrons, and neutrons in this atom of radon. Again, easy one, the number of protons is the atomic number. In the type of notation that we're dealing with now, which is at the bottom left, that appears at the bottom. Since it's a neutral atom, the number of electrons is the same thing. And once again, 211, the mass number, tells us the sum of the protons and neutrons, meaning 211 minus 86 tells us that there are 125 neutrons. What if you're given the alternate form of notation? Try this now. How many protons, electrons, and neutrons are in this atom of gold? The issue here is that the right-hand form at the bottom doesn't show us the atomic number, so we don't know the number of protons or the number of electrons. However, chemists always have an important resource at their disposal, and that's the periodic table. If it's an atom of gold, it has 79 protons always. That doesn't vary. As long as we know that the atom is neutral, that means that the number of electrons is also 79. And then we do the same thing, subtracting 198 minus 79 to get the number of neutrons. One important final note here is that the mass number of 198 is not the same thing as the number that appears at the bottom of the periodic table. Common misconception is that they are the same. Atoms that have different mass numbers are called isotopes. What's the difference between these isotopes?